Steve. Today I'm going to be critiquing this. I've actually wanted to do this for a very long time, just haven't been able to. I am doing this live. Yeah, I'm in my recliner. So if you hear any cats or fighting or anything in the background, that's what it is. Hopefully, no pop ups will come up while I do this. But we're going to do this. The Catastrophic Plate Tectonics, a Global Flood Model for Earth History, or CPT. That's Steve Austin. He is one of the three young Earth creationists with PhDs that go around and try to fit modern geology. I'm not going to say secular geology because there's only geology. But you know what? Actually, if I have to, I will. If you hear me say secular geology, I'm talking about actual science of geology to differentiate it from this. And you'll see why as we come along here. Now, it's him, Steve Austin, Baumgardner, and Snelling. Those are the three. And this is public. This does not have a copyright on it as far as I know. And I can just do this with you. I would love to do the Is Genesis History series, but that's all copyrighted. Anyway, let's get back to this. 2009 is when this came out. All right. So it's been a while. And I, of course, will, take you through things as need
A
be.
bunch of us
Hold on.
have been thinking about this subject. I was the leader of the group, started the group. John Baumgardner, PhD in geophysics, was involved in our group. Russell Humphreys, a pure physicist with experience in earth magnetism, he was in our group. Andrew Snelling, a hard rock geologist, what we call an igneous and metamorphic petrologist, was in our group. And Larry Vardaman was in our group, a climatologist.
Just so you guys know, I'm not going to talk down about these guys. I'm going to attack the model. Well, it's a model in the sense that it's presented, but we'll get back to that as we go through.
And meteorologist, and Dr. Kurt Wise, a paleontologist, was in our group. And we started meeting and talking about this issue of plate tectonics and catastrophic plate tectonics. And over the years, we have built a kind of position statement that we think should influence our thinking and other people's thinking. And if you look at the Earth, you see something remarkable about it. Remarkable about the Earth. We have two kinds of landforms on the Earth. We have continent, we have ocean floor. And so we should understand the continents and ocean floor. I'll call your attention to most of the planet, about 70% of the planet is ocean floor. And the ocean floor is...
He's talking about on the surface, but I think you all realize that. Obviously, out of the whole planet, it is not.
Lower elevation, about 12,000 feet above sea level. And then the continents are expressed above sea level, about 2,000 feet above sea level.
Yeah, Earth exhibits what we call a bimodal distribution of topography, meaning you have a lot of ocean. It goes up a lot of ocean, not a lot between, and then a lot of continental crust. Mars is trimodal and Venus is unimodal. That tells us those two don't have plate tectonics.
That's remarkable. Well, I'll talk about the tectonics of the Earth, the tectonic models, various tectonic models, especially because they go way back in the history of things. I'll talk to you about the pre-flood Earth. I'll talk about what was the physical cause of the global flood. Try to pose that question, ask it, and give some answers. And then I'll try to think about can be modeled in a catastrophic way. I'll talk to you about sediment transport.
You have to remember something here. Just because you can model something doesn't mean that happened. I've said this before many times. It has to fit the data. It has to fit what we observe. Interpretation in hard science has to be based on empirical evidence, data, facts, all that. And it should fit in with other disciplines. We'll come back to what I mean by that. So just because I can model something doesn't mean that's what happened. And I've said this before. I can model a stop sign growing out of the ground. That doesn't mean that happened. Now, there's different types of models. I'm just going to mention them quickly. You have computer, which is what you're going to see. You have physical, which is if I physically build something. You have mathematical. And those are the only three I'm going to go into. There's a couple more. but those are models. As long as it makes predictions about what you're talking about, it's relevant. Like I can show you the orbit of the moon around the Earth and show you the phases in a physical model, but that's the limit of that model. I can't extrapolate that model to the entire movement of the sun through the Milky Way, with the Milky Way through the local group, through the universe, because that's not the focus of the model. So that's key to remember too. A model is focused, it doesn't have to describe everything. That's not its point. And that's something I've noticed young Earth creationists have a problem with. And that's obvious. They think they need to model everything all with one explanation. This is often why you'll hear, I'll be talking about Precambrian geology, maybe the Mesoproterozoic, and somebody goes, well, evolution is false because yada, 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 yada. It has nothing to do with evolution. It's don't mix everything up. And their analogies are like this too. Like their 747 analogy or Jeep analogy, whatever it's called, they're all variations of the same thing when they sit there and say, but it's not really an analogy because they try to draw direct equivalences. And analogies in science, you'll never see them in papers, for one, but you'll see them in textbooks because they're supposed to make you understand in something that you don't understand using something familiar. So it's going to be flawed by nature. It should be focused. Okay. It's never to be extrapolated, and it has to be appropriate for what you're doing. Now, the 747 model is that, oh, if I put all the pieces to a 747 laying on the ground, they'll never assemble into an airplane and fly away. Yeah, of course they won't. And that's not really an analogy anyway. It's not really appropriate. It's too encompassing, for one. Now, if I sat there and said, my heart pumps like some sort of, valve on that plane, I could use that. That's better. But then they take it and sit there and they extrapolate it to the nth degree. They continue to go on with it and make equivalences from it. Analogies aren't evidence of anything, neither are arguments or claims. Evidence based. So that's the kind of stuff you got to worry or look out for too. All right, let's continue here.
Mechanisms in the flood, a little bit about volcanoes and earthquakes, how the flood ended, the post-flood geologic process, the post-flood climate what we have today, and then a little bit draw some conclusions. All right, so there we go. We got the overview. Okay, tectonic models. Ancient literature, way back, deals with tectonics. Plato's Atlantis, okay, lots of other.
Plato's Atlantis has never been demonstrated to be something other than a story. See, they're trying to connect, say, this is what is done. But those of you who don't know anything about Atlantis, but I say that, you might know, oh, yeah, it was a lost continent that sank into the sea. That might be the limit of what you know, and he's going to play on that. But it's a story. It's a story. When somebody tells a story, that's not evidence of anything other than telling a story. And people might be like, well, in ancient times they had to do word of mouth, but this is Plato. They had written language, and so that doesn't work.
Things regarding ancient literature. The statements of Scripture regarding tectonics.
Those will be cherry picked to the nth degree. You'll never see anybody go through the book of Genesis and describe a secular model for any tectonic process because it has nothing to do with tectonics.
The theory of Antonio Snyder. Remember Antonio Snyder? I explained last night, the author of Catastrophic Plate Tectonics in 1859.
Okay, I just brought up Antonio Snyder just quickly. I did already look through this Wikipedia article. It seems to be okay. You guys know that Wikipedia is not evidence of much of anything, but I looked through it. I don't see any problems. He didn't model catastrophic plate tectonics. He did have the concept of the Earth has changed size. We've seen this with many models in those old days. And by the way, you can see when he lived. He didn't even make it to Wegener. So, people have noticed these continents fit together long before him. And one of the ideas was that Earth, the continents were all together and it's gotten bigger, and that's how they moved apart.
Modern theories of continental drift and plate tectonics. Antonio Snyder's theory of continental sprint was slowed down to make the modern theories of continental drift and plate tectonics. Well, ancient literature.
Continental drift is not plate tectonics. Wegener's hypothesis did not become plate tectonics. I've said this before. Wegener's concept was pretty good. He was actually the first one that actually kind of like fit everything together into Pangea, but he didn't really provide a mechanism for how the plates moved. He was this close. And at the time, they didn't have a concept of plates. What one of the things that people thought was continental drift, like you had a solid ocean floor and featureless. Continents sat on top of the ocean floor loosely, and things like waves would move it around, or the rotation on Earth's axis would slowly move it about. They had no concept of plates whatsoever. Hence, continental drift is not plate tectonics. But I'm going to talk more about plate tectonics when we get
Has
through
a
this.
theme. The Gilgamesh epic and the
Gilgamesh, these are, like I said, stories. They had writing too, but this isn't something you can take, Steve. It's really not. And that story has nothing to do with tectonics. And it's not even global, I don't think. No, I don't think it is.
Greek, even American Indian tribes have tectonic elements to them. What does Scripture say about the formation of continents and ocean basins? Genesis 1, verse 9 says, God said, let the waters below the heavens be gathered together in one place, and let the dry land appear, and it was so. And then it goes on to say, in the gathering together of the oceans, he called seas. Okay. All the
Yeah, that has nothing to do with anything. Whatever.
fountains of the great deep were broken up in Genesis 7:11. A great tectonic of
Yeah, they Fountains of the Deep he's going to come back to that. That's one of the things, that they like to fall back on. But it just says Fountains of the Deep opened up. There's no description. It's vague. That's not science, Steve. That's not hard science.
event. The fountains of the great deep, and then were broken up.
By the way, if I say that's not hard science, Steve, I'm not digging Steve. I'm just digging the fact using the Bible as a book of science doesn't work. And there's a lot of young earth creationists that don't like this because they know it doesn't work. Whenever you try to use a secular concept to fit into a literal interpretation of the Bible, it doesn't work. And that's fine because the Bible's not a book of science, it's a book of faith. So it doesn't matter. I mean, it's almost as if a lot of young earth creationists, especially evangelicals, don't worship God or Yahweh. They worship a book. And that doesn't help anybody.
The Hebrew word is bekah. Bekah means to split open or cleave. And all the high hills under the whole heaven were covered. You notice that the flood begins on the ocean floor, evidently, with the fountains of the great deep being broken up, and then it proceeds to the high hills on the continents.
Yeah, but I've seen young earth creationists model that actually in a video I did not very long ago. By the way, it is March 20th. It is the spring equinox. So celebrate if you're a heathen. Don't if you're not. I don't care. But it's also Alien Abduction Day. So go watch yourself a really bad alien abduction movie. Sorry, I got sidetracked.
All the high hills on the under the whole heaven were covered. And it
Oh, back to that. Sorry. The model I saw, which is in one of my videos before this, was of the ocean kind of like mounding up as if it's like, you know, as if it's like the Blob or something. That old movie, the remake. Oh, that's the thing. What are you guys doing? There's the original Blob. As if the ocean was just a blob that just moved over the continents. It's like, whatever. But of course, no mechanism is ever used to explain why that would happen.
it's a Hebrew superlative. You cannot say it in a more concise
All right, I'm going to try to skip. No, I'm going to play this whole one through. This one's only an hour. I will try not to ramble.
way that the floodwaters covered everything. Antonio Snyder's map of the pre-flood Earth, the continents joined some way, and the idea that the continents split apart as a result of the flood.
I don't think Antonio ever said that. I don't remember seeing that anywhere, but that just might be him saying, well, Antonio's motto explains the flood. I know language is a tricky thing. But just so you guys know, I have bad allergies right now. So if you hear me sniffling and stuff, I apologize.
La Creation Essays Mysteries de Volier, published by Antonio Snyder, 1859. Bad year for plate tectonics, especially catastrophic plate tectonics, and publishing The Flood, because the world didn't want to hear more catastrophic ways of thinking about the earth. They wanted to hear uniformitarian thinking.
That's a common trope of young earth creationists, and that's not true at all. We did not wake up in 1850 because if you saw, Antonio was basically alive the entire 19th century. What was that? He was born in 1802 and died in, I don't know, 85 or something like that. So, right in the middle of his life would have been when we started really getting going in geology. Geology took a little longer to get going than some of the other hard sciences like physics and chemistry because it's hard to experiment because the technology was crap then. We can do it better now, but it's hard to experiment these large scale continental movements. So, they just went with what they had. And at no point ever did a group of geologists get together and say, hey, reject everything from the Bible and do a secular, interpretation. By the way, sign this statement of secular geology saying you will always reject the Bible. Come on, sign. That never friggin' happened. And I hear this over and over. It was a gradual thing. They actually started with the Bible because they didn't know what to do. They didn't have anything else. Well, the Europeans and North Americans, because they're the ones that started the science of geology. I mean, if it would have been some other people somewhere else, they probably would have gone to their religious text too. The Bible isn't the only one. So it doesn't matter. That statement, it bothers me. It gets into my because that's not how it happened ever. Ever.
And of course, Darwin ascended to popularity about that time.
Steve, Darwin has fuck all to do with plate tectonics. Let's move along.
It wasn't until about 1910 that Alfred Wegener dusted off Snyder's theory of catastrophic plate tectonics and put it
I'm just gonna.
in
This
an
is.
evolutionary time scale.
There's no such thing as an evolutionary time scale either. This has nothing to do with evolution. This is something else young Earth creationists do. I've told you that before, how I'll talk about Mesoproterozoic sediments in a video, and the first comment is, well, yeah, well, how does life evolve from non life? The fuck do I know? I don't study abiogenesis. I'm not a biologist. These are not similar concepts. Yes, physics, everything boils down to laws of physics. Chemistry is referred to as the central science, and geology does involve physics. There's geophysics, there's geochemistry, there's geochronology, all this stuff that fits in with other sciences. But they all kind of validate one another, but they all don't reach into everything. There's plenty of planets out there in the universe that don't have any life, hence no evolution. So they just need to stop that. That's just one of those things that bothers me too. Calm down, Steve. You're gonna calm down.
Involving millions of years. And then continental drift was ignored.
Actually, they had no idea really in the mid 19th to early 20th century how old the Earth is until we started getting radiometric dates in, and the ages varied wildly from a few 100,000 years to a few 100 million. No one guessed 4.5 billion though. That was a surprise, but no, there was not even a consensus on how old the Earth was then because nobody knew.
Until 1963, right in there, and then seafloor evidence became available to suggest that the giant mountain range around the ocean basins was a result of a plate divergence.
He's talking about seafloor spreading at a spreading center, a mid-Atlantic ridge or something like that. What happened to mid-continent ridge and failed, that kind of stuff. That's your spreading centers out, your rifts. They do form mountains, but they're at the bottom of the sea and they're not very tall. Any of you who have seen, let's just do this, has them. This is the East Pacific Rise. actually, and very few people are not, are most people are unaware of this rift. The ocean is spreading apart faster. It's spreading apart faster here than it is in the mid-Atlantic. And that's probably why the basin and range is starting to split, because North America is riding over this ridge. Now, ridges or spreading centers can get subducted. I know it seems weird, but we know this happens. It's happening right here. But, whether or not North America will ultimately split or not, I don't know. Anyway, these are the mountains that he's talking about. Let's get back to where we were. Let's just close all that.
And seafloor spreading became recognized among geologists, and some of the elements of plate tectonics became very popular in the late 1960s. Well, what happened to the floor of the pre-flood ocean? That should be probably one of the primary.
Notice he's starting with the assumption that the flood happened. Now, those of you that know me and know about science know that you don't start at the conclusion and work backwards. However, their defense is this is our hypothesis, and that's fine. You can have a hypothesis that says that. However, the data against that is so vast that you're just scraping up a vertical cliff with no fingernails. It's so at this point, the body of evidence is so much against it. You are starting at the conclusion. If you had proposed this in 1850, that would be different. Okay, but it's not 1850.
Questions that we should answer. Now, we don't have a lot of familiarity with the ocean floor directly, but we have all the geophysical data about the ocean floor.
It's
And if you
true.
look at the Pacific Basin, for example, on this image of the Earth, you can see that it's not just a ring of fire with volcanoes around it.
Just so you know what the Ring of Fire is, subduction zones and whatnot around the Pacific Ocean, because most there are spreading centers in the Pacific Ocean, like the East Pacific Rise, but most of it's going through subduction. And this is it. What that means is you get a lot of volcanoes here. That's the Ring of Fire. That's all it is. By the way, the Pacific plate is the largest plate on the planet, so it's unstable. It will probably break at some point. And the second largest plate on the planet, believe it or not, is not Eurasia. It's North America. Anyway, I digress.
Is a basin of fire. Okay, but that because that ocean floor is full of tens of thousands of volcanoes on the ocean floor called seamounts and guyots. Maybe you've heard about those. And there are volcanoes around the Pacific Rim, yes, but the whole basin is volcanoes. And so
Um, I think he was starting to talk about something else here and got mixed up and tried to salvage it because that didn't make any sense to me. I'm not saying, he's lying or anything like that. I'm saying he just messed up and he tried to save himself. Because I will say one thing for Steve, like me, he's a good speaker. He can pull stuff out of his head and he doesn't go, a lot either. So I'm not scripting this, just so you know. So, I'm going to get wonky when I'm trying to bring up images, but usually in speaking, that doesn't happen with me. But, I have other issues which are talk for
the
another
ocean
time.
floor is a volcanic feature dominated by volcanic rocks. The typical rock is called basalt, and it's erupted and the volcanoes erupt basaltic lavas on Hawaii, and that's the kind of rock that the
This is generally true. Most of the ocean floor is mafic rocks like basalt, and Hawaii's a hot spot. It's not a spreading center. It's not on a spreading center, and most of the Ring of Fire is subduction zones too. It's not spreading centers, but we do get intermediate and felsic uh, ocean floor. That it would be the case in Zealandia, but that's a talk for another time. Look that up if you would like. I'm not
the
going to do it
bottom of the
here.
ocean floor is made out of. The ocean crust is thick, but not as thick as the continents,
That's true.
maybe 10 kilometers thick. The pre-flood Earth, let's talk.
Oh, but something I'm going to clarify first because I don't know if he does this. Lithosphere. He talks about the crust, and we usually think about that being, involved in plate tectonics, and it is the crust, but the crust isn't it. The crust is on top of this mantle layer Uh, let's just do this. Top of this mantle layer. Oh, this is going to be a lecture, so I'm just going to fast forward through it. Let's see if there's anything here. All right, you see this here? This is mantle. This is the lithosphere. The crust is on top of that. And the crust and lithosphere together, when talking about plate tectonics, are just talked about as the lithosphere. This upper mantle subducts and spreads apart just like the crust. And it's under the continents and it's under the ocean floors. See, that's what he's showing. The asthenosphere, that's a layer of the mantle. That does not get subducted back into the earth, and he's going about convection cells here. This you probably all know if you've had any, basic plate tectonics: spreading centers, divergent boundaries, mid-Atlantic ridge, mid-ocean ridges. Then you get subduction, you know, uh, boundaries. Oh, collisional boundaries, and that's where your plate gets subducted back under the another plate. Now, the continental plates do not get subducted for all intensive purposes. All right. The ocean plates do, but it doesn't have to be ocean against continent. It could be ocean against ocean. That happens in the Pacific. So, and then we have transform boundaries, which are basically very large strike slip faults. All right. That's just it in a nutshell.
Talk about the pre-flood Earth, and I'll talk about the Earth's internal structure a little bit, about the granitic continental lithosphere, about the basaltic ocean.
He's just trying to say here that most of the lithosphere is felsic, and for all intents and purposes, that is true. He's trying to, I just said I don't go and I did. He's trying to simplify it because most people know what a granite is and a basalt is. I don't have a problem with that for this type of audience, so I'm just going to let that
Oceanic
go.
lithosphere, and here you see kind of the idea.
Yeah, but he doesn't have lithosphere on here, even though he's talking about it.
The Earth's internal structure can be divided into three different elements: the crust, which is silicate rocks, typically a basalt or granite composition;
That's
the
fine.
mantle rock,
Whatever.
which is typically of a basaltic composition but is rock, not molten;
That is true. The mantle is solid. We know this because we S waves move through it. That's how we know. S waves do not move through liquids and gases because you can't shear a liquid or a gas. So the mantle is solid. It just behaves plastically. I've done demonstrations of this in entire lectures
the
on it.
outer core of the Earth is molten.
And when he said three layers, basically he's talking crust, mantle, core. We separate the outer and inner core just like we separate the crust, the lithosphere and the crust together, the lithosphere from time to time. There's many more that's you have mechanical layers and stuff like that, how they behave. And then, like you said, you saw a asthenosphere and all that, but basically you have crust, mantle, and core.
We believe the inner core is solid.
Yeah, that's
And
fine.
so the majority of the Earth is mantle, the mantle of
That's
the Earth,
true.
and it's silicate rock. It's oxygen and silicon
Yeah, and it tends to be mafic to ultramafic, but yeah,
with magnesium and iron and other
that's true. Iron and magnesium give you mafic, ultramafic rocks.
other elements like that. Anyway, the mantle of the Earth is this material that
But it also contains potassium, sodium, and calcium. That's how we get our feldspars. Took a minute there to go, but that's usually because the crust has been remelted. Not always. There is those elements in the mantle.
behaves like a rock in earthquakes. We know about its properties indirectly, like from earthquakes, and we think we've found pieces of mantle that have been erupted and quenched, and that
But those are called ophiolites. And yeah, he's talking about seismology of ophiolites, and I've talked to you about ophiolites before. I think I even have a little video I can show you here. Okay, ophiolite happens. Ophiolite happens through a process called abduction, not subduction, but subduction's involved. This is just a generic cross section. I made this. If you want to use it, feel free to. I don't care. But watch what happens. Here's your mafic ocean crust, your mantle, your felsic continental crust, and then I have an approaching island arc. Now, see, I have ocean on ocean. I don't have ocean on continent. Watch what happens here. Let's just see if it'll do it. Oh, if you ever want this animation, it is on my YouTube channel. Just steal it from there. I have a whole bunch of them. Now it's going to start moving. You see one ocean plate's going under another. The island arc, and you see how the split, this green? This green part is ocean crust with a little bit of mantle. It's just got abducted onto the land. That's how this works. And there's actually some ophiolite in northeast Wisconsin. Those of you that know me know I study the Pembine Wausau terrain of the Pinokian orogeny. There's ophiolite there. I don't think I have any easily accessible though. So
The
let's see.
Earth's internal structure can be divided into
Right,
magnesium and iron and other elements
right.
that are part of the Earth. And what we need to think about is the crust and the mantle of the Earth to understand catastrophic plate tectonics. So if you look at the Grand Canyon, you'll see underneath the Grand Canyon.
Everything's always the Grand Canyon, Grand Canyon, Grand Canyon. You can't extrapolate a single location to the entire planet. But let's go move on. I've beaten that horse many times.
The crystalline rock in the basement.
What he's talking about is the Venetian schist and the other, not the Grand Canyon supergroup. Those are metasediments below that. It's the oldest in the Grand Canyon, even older than those level-lying Phanerozoic rocks everybody thinks of when they look into the Grand Canyon. The Grand Canyon has far more than just that.
There you see the Colorado River, and you see the granite rocks down there, granitic rocks, Vishnu complex metamorphic rocks, and Zoroaster granite that make this rock.
It's not only it's metamorphosed, so it'd be nice, but there are non-felsic facies as well.
That's the basement of the continents. And the basement of the continents is this kind of rock that's widespread through through
The cores of continents, basement rock, you can call it that, are called cratons. Sometimes they're exposed at the surface, but that the continents are built from those. But let's just move
the
on.
North American continent. But all continents have this kind of rock as their uh, their dominant rock type.
It's not. It's vaguely true. Like the basement has granitoids at the bottom, metagranitoids, gneisses, migmatites, that stuff. But it's not like it is there.
Rock type is very different from the ocean floor rock.
Plus, we have things like greenstone belts, which look nothing like modern plate tectonic setting at all.
Now, we have lots of feldspar and lots of quartz in this rock. Mineral quartz is most distinctive of the granite rocks of the continent. Ocean rocks have very little quartz. The mineral quartz, they have some feldspar, but they have more heavy minerals like hornblende and pyroxene, things.
I say pyroxene, but hornblende, pyroxene, olivine, biotite, those type of things. You guys have all heard me talk about before in Bones Reaction series, all that fun stuff. That this is all fine.
Like that. And granites tend to have biotite, mica, that type of thing.
Well, you guys that know me and have used Bones Reaction series, if you have a granitoid with you can have granitoids of biotite, but they're going to be pyroxene and olivine in those as well. Now, he should be saying granitoid. I know he's saying granitic, granite, because everyone knows what that is. But those of you that follow me know in the Archean, which is probably what he's referring to mostly here, or early Paleoproterozoic, Paleoproterozoic, something like that. We didn't have a lot of true granites on this planet. We still don't know why. What we had were TTGs, tonalites, granodiorites, and trojmenites. I can never pronounce that. Just Google it if you want. That weird one is actually a type of tonalite. But those, in order for biotite to crystallize out, you've got to already be giving up that calcium back to the melt and taking on potassium. You're getting those K spars. And there is some K spar in granodiorite. There's a little bit of it. And in tonalite too, and some have none. But you hit a certain percentage and it becomes a granite, and that certain percentage is not exceeded. Like you don't have a lot of K-spar in there. So that means several reasons we didn't have K-spar in there. And that in that case, if you don't have, sorry, potassium, if you don't have potassium in your melt, you can't make a K-spar. So you would get biotite and everything else down. But in a normal magma body where everything's pretty much equal and homogeneous, what happens is you get olivine on this side, and this becomes a rearranging, and then you get plagioclase on this side, and as that magma cools, that olivine will rearrange to pyroxenes, and pyroxenes are a whole bunch of different minerals, and that plagioclase will start to give up into back to the magma. This side doesn't do that, but it'll start to give back up the magma calcium and take in sodium and potassium. So as you go down, then you get the biotite, and then by this time you have a lot of K-spar forming. Now you'll still have some plagioclase 99% of the time, because if you have too much calcium and it can't bond with anything, it's going to stay there. But you keep going and going. Eventually, muscovite is at the bottom with, what is that, orthoclase? That's a K-spar. So biotite and muscovite for Bones reaction series are very different. Muscovite's low temperature forming mineral. Biotite's that low to medium, something like that. So there's plenty of granitic rocks without muscovite in them. Let's move
A
on.
little bit different chemistry and composition. Okay, well, granite in microscopic view, if you look at it, it's made out of three different characteristic minerals. Feldspar, which is the dominant mineral of the Earth's crust.
Yeah, and those can be broken up into plagioclase, which are calcium-rich feldspars, and alkali feldspars, aka K-spars.
Quartz, which is a silicon dioxide
Yeah,
mineral,
that's fine.
and typically mica or biotite, what's called iron mica. That's a typical granite. And
He's talking about the mafics, but they are minor in a granitoid, because if you have too many of them, then you have a mafic rock, and you have to use those classification charts. But pretty much most granitoids have one of three things, and you don't have to talk about the mafics because they don't make up the majority of the rock. It's actually, we'll just say feldspars, put both of them together, quartz and foids. Those of you that heard me talk before know that foids are not or cannot form with quartz. So when we plot this stuff, let's see this here. Let's pull this one. This one's fine. I've looked at this many times. I don't have a problem with it. This is basically your QAPF plot for those of you that follow me, whatnot. See, these are your granites over here. Back in the Archean, Paleoproterozoic, mostly Archean, almost all that stuff plotted here. These are not true granites. You'll almost never see stuff up here, but in the Michigami of the Upper Peninsula, which is also Precambrian, Pinocchian, we do see some quartzolites. Those are very rare. But you see here you have an F. This is not feldspar. These are your feldspar. Alkali feldspar, K-spar, plagioclase here. This is foids. Because if you have quartz, you cannot have foids. If you have foids, you cannot have quartz. So if you have quartz, everything from here down, discard it. If you have foids, everything from here up, discard, then plot as you normally would. Okay, let's move on.
because of those dominant minerals, and because feldspar and quartz are the dominant minerals of granite, they this rock has a density of about 2.8 grams per cubic centimeter. Okay, 2.8 grams per cubic centimeter. In other words, it's 2.8 times the density of water. Okay, that's a good way to think about it. Okay, and basalt in microscopic view, you see something different. You see the texture is finer, less crystalline, because it's typically...
This is petrology. Steve, I know, is not a petrologist. I'm okay with the way he's explaining it, because I'm sure this is a creationist conference. There's probably not too many actual scientists in that audience. I could be wrong. But the way he's speaking makes me think there isn't, so we're just going to roll with this.
By contact with water or cooled differently. You'll see some larger minerals in there. Those are some feldspars. And also see minerals that are iron magnesium minerals. such as pyroxene and those kind of minerals. And because of the difference in composition, the basalt rock.
Hornblende too. That's another one. And this might actually mostly be hornblende. I can't really see, the picture's fuzzy, but there are some feldspars in here. You can have a tiny bit, just like you can have a tiny bit of mafic rocks in a granitoid. You can have a tiny bit of felsic minerals in a mafic rock.
Can be 3.2 to 3.0 grams per cubic centimeter.
We'll let that go.
So the density of granite is about 0.5 gram per cubic centimeter less than the density of basalt. So basalt is higher density, about
That's true.
3.2 grams per cubic centimeter, and the density of basalts are higher.
Never going to make fun of someone
granite.
tripping up. I do it all
Okay,
the time.
why are there oceans? Okay, here's the brief explanation. You see the continental crust there is, the continental crust is thicker. And think about the difference in density between continent and ocean floor.
Yeah, ocean crust is thicker.
The thicker continents
thinner
being
than the
lower
continental
density
crust.
cause them to rise, okay, higher, and they displace the root of the mantle below into the
That's fine.
mantle below. The ocean crust is thinner but higher density, and so it floats lower but is not as thick. And so it allows the freeboard of the continents over the ocean basins.
That is not accurate, but for someone who doesn't know anything about tectonics, I think it's okay. We'll just go with it. Basically, in a nutshell, the continents are thicker because they're less dense, and the ocean floor is denser, so it doesn't stick up as high as the continents. That's not why the continents are higher up, though. But we'll let that go. That's because you've had collisions and collisions, and that continent's gotten higher and higher, and other factors as well, because we can get basins that fall below sea level. So continental crust isn't always thicker necessarily, or at least really much thicker than the ocean floor. Let's go back to it.
And the principle is like balsa wood floats higher in water than oak wood, right? Oak is higher density, so it floats deeper.
That analogy is actually fine. That's how an analogy is supposed to work. I'm completely fine with that. And notice it was to the point and focused. He's talking about continental crust sticking up higher than the ocean crust. So that was a fine analogy. That's how it's done. He didn't extrapolate. He didn't add to it or anything like that.
And so you think about that. The ocean crust, the oceanic crust, which is dominantly basalt, has higher density. It's thinner, so it floats lower on the mantle of the Earth than the continental crust, which is
That's
lower
DC,
density
continental crust.
So it creates the freeboard.
DO.
So that's what I think it's like.
DM
And so the day before the flood, what does the Earth look like? It has basaltic crust, ocean floor, like we have today, probably largely gone. It has the same continental mass or crust that we have today, just recycled. The day before Noah's flood, we had a similar configuration as we do today, basalt and granite, different continental distribution.
How would he know that? I mean, before Pangea we did, but how does he know that?
But we had the same continental composition. So the ocean basins were probably created on day 3 of creation week with this different rock type.
How do you know that? Fine, let's just move on.
What was the physical cause of Noah's flood? Very good question. Internal and external and internal or supernatural.
In order to believe that it happened, it has to be this. Because internal, external, secular work isn't going to float here, as Noah's Ark wouldn't have either.
Causes. You might think about this. Could the flood have caused itself inside the earth?
And I actually don't have a problem with that, but that wording But creationists, he had to explain it that way because creationists think everything has a cause. Everything that happens had something that preceding before it. That's why they don't think the Big Bang is a thing. And they say the whole, even though Big Bang has nothing to do with plate tectonics, and they'll sit there and say, well, you can't get something from nothing and all that other ridiculous stuff. Assuming there was a nothing before, assuming there was even a before, that those are all assumptions.
Internal cause, or is there an external cause, like asteroid, him hitting the Earth or something? Or is there a supernatural cause, God pushing a button, releasing some trigger or something? Anyway, that's something to think about, external or internal. Genesis 7, verse 11, talks about the fountains of the great deep being broken up. So it has a tectonic theme to it, doesn't it? It has the Hebrew word bekah.
Notice tectonic theme. If it had a tectonic theme and that was obvious before, we would have figured out plate tectonics 2,000 years ago. We didn't. Why? Because it's not talking about plate tectonics. The Bible's not a book of science. It makes no predictions. It doesn't. That's a post-diction. It's like, oh yeah, that I'm going to use that verse for this thing. But nowhere in the Bible is there anything about plate tectonics. You're just pulling stuff to fit the narrative here, Steve, and you know it. At least I think you do. I don't know. I'm not going to get into his motives, but, it doesn't ring of tectonics, was my point.
Broken up or split open. And what are the effects of new hot ocean floor? Okay, new hot ocean floor was produced. And if plates were subducted, then we had new ocean floor formed. A new hot ocean floor may be different than that cooler pre-flood ocean floor. And then we have spreading, subduction, and mantle-wide flow. Those are the processes that have to go on.
I think he means convection with mantle-wide flow, but he may not.
Plate tectonics is going to occur on an Earth that doesn't expand. In other words, a constant volume Earth. The initiation of the flood, well, was it a supernatural mechanism, just the hand of God? Or God slamming the door on the ark or something like that? Or is it an astronomical cause, like a comet, meteorite, asteroid, planet near miss, something like that? Or is there something internal within the Earth, a terrestrial cause, like something lighting off radioactive decay and the heat buildup, or canopy collapse, or some other trigger? Well, the initiation of flood.
Most of those things that he's talking about don't have secular equivalents, so I'm just going to keep going.
Is described in Genesis chapter 7, verse 11. The same day were all the fountains of the great deep broken up, and the windows of heaven were opened. That's the beginning of the flood. And it's a general seafloor upheaval, I believe, something there to it. The fountains of the great deep. Fountains is the Hebrew word mayin, which means water sources or springs of the great deep. Now, in the Hebrew, the word great deep is a stereotyped compound noun. There is no the in the original Hebrew. So fountains, great deep. And so the Hebrews had this very special significance that they attached to the.
Steve, this is complete speculation. You're not a linguist. This is just wordplay. Just like, they'll often do numerology instead of actual maths. It doesn't mean anything.
Great deep. And the great deep is obviously a
even
big
if it's
ocean.
True.
Okay, and so this great.
But he can't know what the mind, even if that is the translation, he does not know what was going through the ancient Hebrews' heads. And just because there's no the in their language doesn't mean it's how he's interpreting it.
Deep is what they're referring to. So whatever the fountains of the great deep are, they were broken up, okay, and the windows of heaven were opened. Another cause of the flood was the windows of heaven and the unprecedented downpour of rain.
Windows of heaven. See, this is something I have a problem with because the ancient people knew what rain was. They knew what a thunderstorm was. I don't know. People modern day will say the skies opened up, but the sky didn't literally open up. Was that figuratively or was it actually meant to be window? Because if it was window, then you got problems, Steve. Big problems.
Okay, so from the standpoint of Noah, the windows of heaven are open. But the omniscient narrator that's giving us the text is telling us the fountains of the great deep is in there too. and it's mentioned first. So you see what I'm saying about that cause of the flood. So the origin of floodwaters, the situation before the flood, we had cold, dense ocean crust.
A lot of assumptions here. A lot of assumptions.
And we had higher granite continents. Okay, so this cold, dense ocean floor is going to be replaced by what? Mantle rock that rises to form hot ocean floor of basaltic composition. You see what happens?
That's basically what happens in mid-ocean ridges very slowly. We have physically observed this by going down there. The spreading centers are moving apart, and you have magma coming up. Its composition may or may not be mantle, but we're not going to go deep into that. And over time, these two plates will move apart. We don't observe where he's going. I know where he's going.
Here, when you replace cold ocean floor with hot rock, what happens? It rises because hot crust is lower density than cold crust. If it's
That's
made out of
fine.
the same material, mantle of the earth.
Actually, the mantle's solid, but this is melt because one of the ways you can melt a rock under confined pressures to relieve that pressure or introduce water, something like that. So you could melt rocks at a lower temperature than you normally would.
It would be warm or hot, and that what does that do naturally? It raises the floor of the ocean. And so we have internally within the earth a catastrophic mechanism to unload the continents or unload the ocean floor, unload the ocean onto the continents. Okay, the principles of plate tectonics are three.
I'll give him that. All right. Because it's just him forming a hypothesis, even though he started at the conclusion.
We
Let's
have
just go with it.
spreading, we have subduction, and we have mantle-wide flow. Spreading, where two plates pull apart, okay, what happens? It creates a gap, and in that gap, mantle rock, plastic rock can rise, and as it rises into that crack, it melts and then recrystallizes.
It's fine.
And that
Nothing wrong.
forms a new ocean floor. And as ocean floor spreads or moves apart, you form a new rock in the crack. Okay, and then we have subduction, where mantle rock is receiving crust. As the crust falls, then it creates subduction, and then the mantle is deformed, and you see mantle-wide flow. Plastic deformation can occur to rock on a large scale very rapidly. And this is what's been modeled in some of these experiments. Spreading, subduction, and mantle-wide flow. It happens in the mantle. Subduction is the process where the gap forms. Mantle-wide flow, all those arrows indicating the plastic deformation of the mantle.
That's mantle convection. So he must be talking to people who have no concept. But he could say convection. I mean, the average person knows what that is. They've seen pots boil.
And then spreading. Okay, so subduction, we have spreading, we have mantle-wide flow. Okay, computer modeling of this catastrophic plate tectonics has been done on supercomputers, and it's done
2009. Anyway, something I want to say. Originally, after plate tectonics was formalized as a theory in the 60s, 70s, almost immediately, how are the continents and ocean floors going through this? And three basic mechanisms were proposed. Ridge push, which would be at the spreading center. Another one is mantle convection. The convection of the solid mantle pushes the continents apart. And the other one's slab pull. The actual slab, as it subducts, initiates that plate movement. Now, I want to show you something really quick. Plates move upon what we call Euler poles. Now, it's probably going to stop this down or shut this down again. We have 1927. Actually, just let me move to it. There's a couple of videos on YouTube that show how Euler poles move really well. You can think of it like a rotational axis of the Earth, except only a fragment of the Earth is moving and it's not aligned to north-south. Euler poles don't have to be equivalent to the North and South poles. So I'm going to show you those 1927. Hopefully I can remember that. This is very good. I will link this if I can. Fortunately, there are no talking or anything like that. It tells you where it is. I'm going to let this run because I want to give this guy credit. So this is your Earth. There's your north, your rotational axis, your equator, lines of latitude. Got it? Doesn't matter what they are. That's a plate. Watch what happens. Example, plate motion. He has this sliding about the globe, but this isn't a random thing. Plates just don't randomly move and pick a direction. They move in a predictable manner. I mean, something can always mess with that predictable manner eventually, but initially, this is well known. Now, he's going to show you here. Okay, took all that off because it's just making busy space. There's your plate moving. And see those lines there? See how it's moving? The motion tracks are aligned along circles whose centers define the Euler axis. And actually, in German, it's Euler, I believe. But anyway, a lot of people say Euler. I don't care. He's getting somewhere with this. So if it keeps going, that's the path it's going to trace. Come back to where it started. And this is your Euler pole. And that's your plate is going to move around that. Now, it's not as simple as this. The continents don't move as smoothly. There's a lot of friction going on. So, and microplates, subplates that move a little bit, but generally it's along the big plates. So Euler poles are not exact points. They're a little within that area. And sometimes in one area, like if you have a microplate that might be extending a little, like the basin of range, you might have a slightly different Euler pole. But generally, this holds. Okay, you can read that. There's your rotational axis, your Euler axis. Okay, your plate's going to spin around with that Euler pole here being the equivalent to as if the North Pole was the pole that the Earth rotates upon its axis. That is the Earth's axis, and it does. So it's the same thing, it's just not the whole planet doing it, nor does it have to be directly north. Watch this. See how it grabbed that other one? There's more than one Euler pole. And different things will cause that. Talk for another time. So you can move these because plates are rigid. That's key.
Plastic deformation of the
Okay, close
the
enough.
mantle of the Earth can be simulated, what's called finite element analysis, using a computer by breaking the Earth into a series of layers. You see here the layers. And those layers have they're stacked up on top of one another. Each of those little icosahedron layers, you see, looks like the ceiling of a planetarium. The planetarium ceiling, you know, the geometry of that special geometry is used to simulate the mantle of the Earth, and then we can do deformation experiments on it. And then over this mantle 3D mesh, you can lay the continents, and you could subduct the ocean floor, and so that's what's been done with this, and millions of
that basic concept is fine. However, the mechanisms don't work, which hopefully he'll get into soon.
Are hundreds of thousands of these little elements or cells of the mesh can be deformed. This is one of the experiments. It shows the a continental configuration such as you see here. See,
This is Pangea. There's something I need to tell everybody if you don't know. Pangea was not the first supercontinent on Earth. Before that, with the rocks I study, mostly you have something called Rodinia. And I actually just saw a wait, let's see if I can get it. Rodinia, because this is a most recent reconstruction. YouTube pre-Cambrian seminars. So this is the most recent one, and this is a great channel. Please go to it if you can. And they uploaded two at once. Oh, it's great Irrational Global Tech. They uploaded a bunch at once. Rodinia, this is it.
Okay,
Okay,
good morning, everybody. Welcome to BSPG.
just so you
Um,
all know, we're going to see a reconstruction of the supercontinent Rodinia, a modern or the most recent. Would you stop that? And there's been many different configurations. This model has Laurentia as the center, which makes sense. But please watch this channel. I mean, there's some great stuff. Dalziel 97 is the same guy who with Dot did Baraboo in 1970. So you have this. Let's see where he goes here. He does talk about Pangea and stuff because it's another supercontinent. And Pangea, we pretty much have locked down. All right. This is Rodinia, 97, 2022. This is our present understanding. This is East Antarctica. The trans-Antarctic mountains were attached to the west side of Laurentia, Proto-North America. At this time, there was no British Columbia, there was no Alaska, there was no California. Those things would all be accreted later. So that's not even existing yet. So see, here you can see Laurentia, and there's a lot of rifts around the core of Laurentia, the billion-year-old cratons. Here's the craton. Anyway, whatever. I just want you to see Pangea was not the only one. And this is strikingly different because pieces of South America are different places. Europe's up over here. Siberia's over here. Australia's here. East Antarctica. Kapval, I believe, is what that one is. All these micro fragments. Looks, this isn't something easy, but we're getting this. And I've said before that probably within 5 years we'll have it. I think there's 4 years left. So we'll see if my prediction comes true. And before that, like the Pinocchian orogeny, and just after that, the Baraboo, actually post Pinocchian. The Baraboo, you had Columbia or Nuna. It's the same thing. I like saying Nuna because I think it sounds cooler. Supercontinent. Past that, we aren't sure. But those three definitely existed. So there are two before this. Nuna was circa 1.5 billion, 1.4, 1.3, something like that.
North America, Africa, South America, Antarctica, India, see Australia, and then you see Europe, Asia over here, Greenland. Okay, and you have Tethys, this pie-shaped thing here. That's the initial configuration in this particular run. Whether that was the pre-flood configuration, pie-shaped thing here. That's the initial configuration in this particular run. Whether that was the pre-flood configuration, I'm not so sure that's the right configuration. But in this deformation experiment,
Equality, I mean.
we caused the mantle, or we caused the ocean floor to unzip or deconnect from the continent around the western part, the eastern part of the Pacific Basin, and around the western part of the Pacific Basin, and along here. You see what happens. And when you tip this
I just let him run that so he could orient you. It's basically Pangea.
ocean floor, we believe it was cold. It's of the same composition of the pre-flood mantle of the Earth. What would happen? It could sink. In other words, we are modeling the deformation of the Earth, assuming that the pre-flood ocean floor was the same composition as the pre-flood mantle, just
And it's fine to assume that, but you have no evidence to even assume that. That's your problem, Steve.
cooler. And the difference in temperature creates higher density of the ocean floor, and the ocean floor is able to be subducted and sink. Like an aircraft carrier can sink in the ocean, metal is higher density, it sinks. And so ocean floor could sink into the mantle. And in this
That's fine. Don't make fun of him for that. I mean, if the aircraft carrier, it's because it's buoyant, that's why it floats. But if you shoot it up enough, he's right. It's going to sink.
numerical experiment, it's detached along the margin of that supercontinent. In cross section, you can see what's happening. You can see spreading occurring here. You see the cold ocean floor falling into
This is a cross section. I assume red is hot, blue is cold.
the mantle of the Earth. And it's creating mantle-wide flow. And you see those little...
And that would be slab pull being initiated. So far, it's not too different. All right, but it's about to derail this train.
vectors showing you which way the mantle-wide flow is going. So
it's going to derail Ohio style, too. It's going to get bad.
Spreading. Okay, subduction, mantle-wide flow. Here it is. This is 40 days into the event. You see plates have descended almost.
There has to be other factors here that he's not mentioning. There's no reason after 40 days to get this. Why would this happen? We can observe and measure plate tectonics now, and we don't see any ocean slabs reach into core at 40 days or 50 days. We don't see that. So where's your base for this, Steve? What are you putting in there that you're not telling us? You obviously have to be putting in velocities far faster than we presently observe. This is where it's going to start to go south.
Over halfway through the mantle of the Earth. Okay, 1,000 kilometers thickness, so that's fallen quite a distance. And you see over here it's fallen, and then the mantle-wide flow. The velocity of this deformation as it accelerates goes up to about the maximum.
Here's the problem. Now, this is going to be a very simple demonstration. The mantle is solid, but it behaves like a plastic, right? I'm told that. But the subducting ocean crust is still solid. What happens when two solids get pushed into one another? You can't do it quickly without releasing a lot of energy. And I could break this before I break this, whatever. So you've got to get those plates moving at high velocity to get drawn down, subducted into the earth at high velocities, a solid into a solid. And just because it's plastic doesn't mean it's going to move out of the way. If I try to stab this in silly putty or water, let's just say water, even though it's a liquid. If I stab this bowl of water, what's going to happen? The water's going to go everywhere. If I slowly insert it in there, what happens? I create almost no effect. There's a lot of energy in this. There's not a lot of energy in this. And that's the first problem with this whole thing.
Of 2 meters per second. In other words, these plates.
2 meters per second. So that's 200 centimeters per second. Per second. And modern plate velocities at best are 10 centimeters a year, more typically 2 or 3. Wow, that's rough. 2 meters per second. That's going to also generate a lot of energy, right? I've done this before. I'm doing it again. Take your hands, put them together. Rub them together slowly. What happens? Your hands pass one another, right? Now start doing it faster and faster and faster and faster. What happens? You generate heat. And that heat has to go somewhere. Otherwise, my hands are going to burn or whatever it is they do if I keep going too fast. But I can't move it fast enough for that to happen. But that's ultimately what happened if I can't dissipate that heat as quickly as I'm generating it. So how are you getting rid of this heat as fast as you're generating it? Because that's going to cause a lot of heat. This is often called the heat problem, and a lot of young Earth creationists just blow it off or try to pretend like it's a non-issue. But man, this is a lot of heat to generate. This would melt the ocean crust. It would melt it. And what's that going to do? That's going to boil the oceans. And it's going to release a lot of vapor into the air really quickly. Not to mention, it's going to have friction with the ocean. I know the ocean's a liquid, but you can have friction with it because 2 meters a second is a lot faster. Most of the ocean is moving. Man,
we think can fall about 2 meters per second into the mantle.
you think can fall. Why do you think that, Steve? Why?
The mantle is rock, and as the plates fall, there's a liquid area around the plate as it descends, and that low viscosity melted rock allows
The plates can melt due to friction as they descend and bring down water as well. They can do that. And that helps melting. But the bottom of the plates are not surrounded by molten rock, Steve. It's just where it's in contact with the other plate because that heat doesn't have a way to immediately dissipate, but over time it does. So you would literally just melt everything.
the plate to accelerate to about 2 meters per second, a meter per second, as it falls into the mantle.
And you still have the problem of the mantle getting out of the way quick enough. Doesn't matter if it's plastic and that's a solid. You're doing 2 meters per second of something that pretty much has the mass of 3 continents. That's unbelievably ridiculous. I want to see the maths on this. I have to see it. Now, I know he's not going to do it here, uh, and he's probably talking about a bunch of people that don't understand science very well. Because in science, you can model whatever you want, but like I said before, if we don't observe it, such if you can't show it, you don't know it. Essentially, I've heard that said many times. But this model doesn't happen today, and you can't make it work in the past because the planet would boil itself away.
Of the Earth. Here at 60 days, you see what happens. There are crust. There's ocean crust that's fallen all the way to the core mantle boundary.
We don't even know if plates go that far. Some seem to do, but others don't, apparently. So that question still hasn't been answered.
The core of the Earth
But he's going to get to something that we can pick up through seismology that we don't.
is higher density material. We think it's some kind of alloy of iron and sulfur or something like
Iron and nickel with some sulfur.
that doesn't allow the silicate rock to penetrate. And so the bottom of the mantle contains large lithospheric junkyard of the pre-flood ocean.
Junkyard or graveyard. We don't observe this at the core mantle boundary. We would pick this up at seismic reflection, and it's not there. So that would be a way to test this. Hey, we get an earthquake. Are we getting those P waves reflected? Are we getting those S waves? Are they coming through here and changing direction? Because the denser something is, the faster a mechanical wave, like a P wave or a S wave, is going to move through it. So, believe it or not, those waves go far faster through a solid than they do the air. So, but that's a wave. That's a byproduct of it. It's not the object itself. So, we would be able to observe this just by seismology. We don't. We don't see these graveyards or junkyards, whatever you want to call them, Steve. They aren't there. They don't exist.
Floor, and you see what's spread out there after 60 days. Whoops. And here you see modeling the Earth. You can see the continent expressed. The topography is there.
The red's the continents, the green are the ocean, and I think the blue is supposed to be new ocean floor, but maybe he'll explain it.
Okay, what happens? The continent is depressed around the edge, and then water invades. And you see the purple line is telling you where the ocean actually invades. As this subduction occurs along the eastern side of the Pacific basin, as that's subducted under the North American and South American continents, what happens? The continent is depressed, and water enters into the goes into the center of the continent.
Okay, now he's trying to explain epicontinental seas. But those of us that know that Pacific plate going into the North American plate, there's this thing called the Rockies there. So that's actually higher. All right. And other parts of the continent are going to form basins in response, and some of these basins still exist. That's because nothing's getting bigger, and you can't make something new land from land that doesn't exist. When I mean by that, you can't make new Earth material from something that's not the Earth unless it crashes into it. You know what I mean? Anyway, sorry, I'm getting a little twitch eye here. So what he's getting at is trying to say epicontinental seas will form, like the Sauk sequence, even though Sauk sequence is not the only Paleozoic sequence in North America. Tippecanoe, Kaskaskia, Zuni, all these other ones. I don't know if he's going to go into those or not. But you see, their flood starts at Pangaea. We have vast Precambrian metasedimentary rocks even through North America. You had the Belt Purcell Group, British Columbia, Idaho, Montana, essentially. You have the Huronian Supergroup, Ontario, its equivalents, the Upper Peninsula of Michigan. You have, they're ridiculously thick. You have the Sibley Group, Ontario. Those are just the three off the top of my head for right now. Okay, so we have these massive Precambrian sediments, and then not to mention the Grand Canyon Supergroup, which is another one. I believe that one's also Mesoproterozoic. It might be Paleoproterozoic. So, how do you explain those? Were those just poofed into existence? Or do you have to incorporate them into this? Because they show a different continental arrangement. Rodinia or someplace between Rodinia and and Nuna, or between Rodinia and Pangaea. So you have to explain that. And this doesn't explain that because it starts at Pangaea. And we can do paleomagnetic data as well, but I might come back to that.
And of course, the hot rock is formed in the
Hot
crack between the supercontinent as it opens, and what do we see in there? That's probably the fountains of the Great Deep. Here it is at 60 days into the deformation.
I think somebody would have noticed this going on. I think if they're going to notice the windows of heaven opening up and the fountains of the deep opening up, they're going to notice the continents whapping and whipping around. But no one says anything. No one.
Experiment, and you can see a significant part of the Atlantic Basin has been formed as the supercontinent breaks apart. And the Indian Ocean Basin is forming. And the vectors show, here's a vector view showing you the velocities that are attained. The maximum velocity here at about 60 days on the surface is about 1 meter per second. That's the maximum velocity. If you think of Africa staying put, you can measure the velocities relative to other things. A polar view, you can see looking down on the Arctic Ocean as it's forming from the plates diverging. Again, meter per second water maximum velocity.
And this whole thing was supposed to jumble the oceans up so they just go across the land. I don't know if he actually says that or not, but I mean, this would just melt the surface of the planet.
And this is view from the South Pole. You're looking at Antarctica there.
All right, let's
and here
I'm going to skip this. You guys don't need to know all this.
The North Pole and the South Pacific Basin on the South Pole, North Pole being Africa, South Pole. If you hold it like that, the Pacific Basin or the ring of fire goes around the Earth like an equator. And so that shows you something of the spherical geometry of how this plate subduction occurred on that kind of Earth.
That's a correlation and an observation. Whether or not it means anything, I don't know, and it depends on what you mean by sort of equator, because it's not a straight line. So I would say that's grasping straws, and like I've said before, the Pacific Plate's already unstable. It's too big, so it's probably going to split sometime in the future.
And so you can actually see that it is a straight line, okay, across. And there's the Cordillera.
No, it's not a straight line. It comes to the Aleutians here. Aleutians comes down the west coast, cuts through the Baja California like this. And from here it goes like this, and it comes down and it goes like this. This is nonsense.
Deformation
We're just going to go past it.
In here under Washington, but the great mountains in the southern part of Alaska, that would be Wrangell, St. Elias, Chugach Range, because of places like that. And here's the
yeah, that doesn't have this. It's talking about continental accretions, whatever.
Right, plate subduction occurring against a continent what happens? A conveyor belt moves sediment from the ocean floor where
The ocean floor, he's going to get into the sock sequence, and they love the sock sequence. The basal part of it is a sandstone, or it's a quartz arenite. There's not a lot of quartz aranite in the abyssal plane of the ocean. That's not a source. This mechanism, this model has to match reality, Steve. It has to do it. And if it doesn't, then it's discarded. And this is easily falsifiable.
to the edge of the continent, it doesn't want to be subducted because it's low density. Clay minerals and quartz and things like that are lower density. They don't want to go down with the
That's
plate.
true.
The cold plate can be subducted, but the sediment on the cold plate doesn't want to be subducted.
It can be,
because
but
it's low density.
usually it doesn't.
So we have a conveyor belt that moves sediment to the edge of continents. And then what is happening? We have tides and we have huge waves generated by the earthquake activity of the tectonics. So imagine a magnitude 8 or 9 earthquake here in western Washington due to plate subduction, and then imagine a continuous line of magnitude 8 or 9 earthquakes continuously.
And nobody noticed this. Nobody thought to mention this at all in the Bible. I wonder why, Steve. Because they had no concept of plate tectonics. That's why. And I've already gotten into how this doesn't work in other
For
ways.
a year's period of time. Okay.
Yeah, a year. That's how long they think the global flood lasted.
That's the kind of thing you need to imagine if plate subduction is happening rapidly, like we propose. Large rocks are
Yeah, but you'd melt the crust and the oceans would boil away, and you create.
are found in the bottom of Grand Canyon, big boulders like this 200-ton boulder 20 feet in.
They like doing this, and they actually, he's still around. He's pretty elderly now, but fine. He gets. They did a video with Eric Hoven, Baraboo. You guys should go watch that. If you want, I do have an older version of it on my channel, where not an older version, a trimmed down version. These boulders are common when seas transgress. It happens at Baraboo, but not everywhere around Baraboo. These boulders are not everywhere in the Grand Canyon. If you're sloshing, kicking, and stewing things up at that type of magnitude, we should see this everywhere. And this is the great unconformity. They love to talk about this, but this isn't global. We had sediments being deposited straight from the Neoproterozoic into the Phanerozoic. There's into the Cambrian. Sorry, the Cambrian's the first period in the Phanerozoic eon. Paleozoic's the first era. So this is not everywhere. Not to mention these rocks are all locally sourced. I won't find Baraboo quartzite in here. Okay, I won't find a chunk of Greenland in here. There's reasons for that, Steve, because there was no sloshing of the oceans from some ocean crust moving 2 meters per second, spilling everything onto the land. This was processed over time.
Very abundant. In the Kingston Range in Southern California, we have large blocks or mountain pieces that have slid. And in this illustration, I'm showing you a kilometer in thickness slab of rock which slid horizontally over the surface of the earth in a layer full of other broken pieces.
I don't know the geology of this enough, and I don't know if he's talking about a modern slump or a detachment block. I don't know, so we're going to skip it every time he talks about it because I just don't know. So
this, I believe, is the beginning of the flood in the Mojave Desert. The Kingston Peak First.
I'm going to see if he tells you where this is even from.
Okay, not only do you see large gravity collapse features like the big boulder deposits, but we see supercurrents. And evidence of flowing water creates supercurrents. And these sandstone layers, like at Zion National Park, have this diagonally tilted layers called cross-bedding. And cross-bedding is...
Okay, let's do this. All right. National Park Service is generally pretty good at this. Carmel Navajo sandstone. I thought that's what that might be. That has to be a picture of the Navajo sandstone. This is a very widespread in the area Mesozoic deposit. I do know that much about it, and it's a quartz aragonite, and it does show crossbeds and stuff like that. But notice you don't see a lot of fossils in it. This was likely sand dunes of some kind. Here you see a transgression again. But this was some sort of land based aeolian deposit to get this type of stuff. Some of it might have been fluvial, but cross beds, especially big planar ones, indicate aeolian. It's hard to get that from any flowing water. So, I mean, I'm not going to say it's impossible, but this is Mesozoic. All right. So this is so much further up the Kaibab, I think, is at the Grand Canyon. That great unconformity where his flood supposedly started isn't here. It's way down here somewhere. So why is he showing a picture of the Navajo sandstone? It's not in context. This is out of context. This has to be the Navajo.
It was a primary feature.
Let's see. Depositional environment. See if I'm right. Hospital. Windblown sand dunes in a vast ancient desert. So this isn't even water lane.
Of many sandstone bodies provide evidence of deep water, fast-moving current.
This is windblown, Steve. Navajo sandstone. You're not even showing the proper slide. It took me, what, a couple minutes to find what this is? And I'm not going to say call you out because you're not telling them what this is. This is the Navajo. This is Aeolian, the crossbedding and stuff like that. That's a convenient omission.
Not wind
Say
deposits.
that.
This is not a dune. This is
Oh, yeah, it is a dune. Why isn't it a dune? Because you said it wasn't? I want to see you produce this pattern in a lab setting with quartz aragonite with water moving as fast as you say it was.
deposited by water. We have water going over the continent at about a meter per second. That's what the stable velocity.
The second the oceans start coming up onto the land at a meter per second, friction is going to take over. We'll assume the planet hasn't melted yet. Friction's going to take over. What's going to happen? It's going to lose energy, that wave, very fast, and it's going to collapse. You're not going to get it going all across the continent from the Pacific to the Atlantic, starting at a meter per second. It's not going to happen.
For forming large underwater dunes. And these are called sand waves. They've been seen on smaller scale in tidal estuaries.
Yeah, smaller scale, because we don't have big ones like that, because it's not the same depositional environment.
In the Golden Gate in San Francisco, the place, but they're over widespread areas. And so continent. And there's a person there for scale. See the person right there for scale, so you get some idea. These dunes are huge in the sand bodies and provide evidence of fast-moving water, about a meter per second water velocity, which is consistent with that meter per second plate velocity. And over the North American continent, we have a buried sandstone layer called the Sauk sequence. And there's a Cambrian sandstone that's in the Grand Canyon and in southwest.
You guys have heard me talk ad nauseum about the Sauk sequence, but we are going to bring up the sequences. North American. Okay. First of all, like I've said before, the great unconformity is not continuous. It's not even continuous over North America, for one. Okay. So that's a problem. Am I going to get a picture here? Somebody that's a similar thing. All right, this is a PDF. Hopefully, I'll be able to. Why can't I look at it? Oh, because I'm in Firefox, it doesn't download at the bottom. It downloads at the top. Okay, this is okay. It's okay. No problem with this. Okay, here we go. The basic sequence is, oh, you got drawings here too, an illustration of the sequence. Here you have the sock. The sock is actually divided into three, I think, sock 1, 2, and 3. Tippecanoe, Kaskaskia, Abroska, Zuni. And then the Tigis, I forget how to pronounce it. But you can see they go from the Cambrian to Cenozoic. So this would be the seas. And as you can see, the seas transgress and then regress, transgress, regress. I've showed you this in a previous video, maybe the one even right before this, about how those deposits are made because those were misrepresented in 2004 in a bad video, a bad young earth creationist video. So these are what they mean by these sequences. This, he's talking at sand like the whole thing is a sandstone. Let's see if I can sock sequence. Here we go. This is from Illinois. I've shown you guys this one before. This is the Illinois basin. We'll just do that. See these dots? That's your sand. And these are supergroups. Potsdam. Nobody even uses that anymore. Subsock. See, we have carbonate. Almost all these sequences have carbonate to them. Okay. So your sock is this, I believe, and your Tippecanoe starts here. The sock, I think, ends in the Ordovician, if I remember correctly. Okay? So you come down here, your Potsdam. This would be your Mount Simon sandstone, your Eau Claire, those type of things. And there's a little bit of shale. You can see that in there. But look at this. It's mostly carbonate with bits of sand in it, like the New Richmond and all that, supposed to be anyway. But you can see there's an unconformity in there too, with erosion. And then the Tippecanoe sequence came in, and it's is that? Yeah, I don't know. The St. Peter. Where's the St. Peter in here? I don't know. I'm not going to try to break out individual lithological units because I could be wrong. So, but I just want you to show you that at the beginning of these sequences, at the beginning of the sock, you had a lot of sand, but you have a lot of carbonate too. Dash lines are mudstones, and your bricks are limestone, and your angled bricks are dolostone. See, look at this. We don't get, it's not all sand. Not all sand.
And Eastern California that goes all the way up into North Greenland and around through middle part of the United States into Newfoundland area. And it goes over, if you assemble Europe against it, it's in Scandinavia. And around the Canadian Shield is this giant blanket of sand. Could that be associated with the onset of the flood?
That giant blanket of sand, as I've already said, is not continuous. We do not call the base of the Cambrian the same lithological unit as we do at the base of the Cambrian in Illinois. We do not do that. The Tapeats sandstone is not the equivalent to the Mount Simon sandstone. The Tapeats is in the Grand Canyon. The Mount Simon is in the Illinois basin, Wisconsin, and Indiana. We can't trace them that way. They do vary lithologically. They don't contain the same fossil assemblages all the way through. So they're not the same thing, Steve. They have different source areas. And all we have to do to find out about source area, those crossbeds he was showing you? It applies for wind. It applies for water. The crossbeds, you measure these, you can get your area of origin. You can see, you get deposits here. Here's your crossbed. That tells me on this crossbed anyway. Let's just use this. This is a planar crossbed too. On this here, this dark line, that's a crossbed. That tells me my source is this way to the left. All right. So I could trace source too. And they don't line up. They don't. So this is common with young earth creationists, this oversimplification, hoping you don't know. And I'm not going to accuse Steve of doing it directly, but there are plenty of others that do this.
As we look around, we see evidence of current in volcanic ash deposits like the Painted Desert
too.
in Arizona. Petrified Forest National Park should be called Petrified Logjam National Park.
I've been there. I got some really good photos of that. Is that
You
from
can
the
see
70s?
the very beautifully agatized logs that are there. Cell structure wood.
This photo does not do it justice. It is so beautiful. It is ridiculously beautiful out in the desert. And you just see this agates, the reds, the white quartz, the grays. Yeah. Is that
Bark sometimes on or peeled off, roots and branches removed. Obviously, these things have been floated. And
why? Why do you just think they've been floated? They're also not at the bottom of your sock sequence. I forget how old they are. I think they're Mesozoic, actually. So why don't we find? I mean, this flood would rip up not just the earth, sediments and rock. It would rip up trees. And if there were people around there then, because Noah and all them, it would rip up buildings and huts and ships, and all this stuff would be incorporated into these units. And they don't exist anywhere in any of it. And I don't want to hear anybody saying, well, what about Mount Ararat, this boat shaped thing, which is actually basalt, right? So I'll just bury that
great,
right now.
a great stranded mass of ripped loose logs. And coal beds are what?
Ripped loose. And why would they be in one location like that? Why wouldn't they be spread apart on the continent?
They're floating mats, aren't they? They've formed from floating mats, and that's been floated around and redeposited. And then so coal is interlayered with marine rocks. So it looks like a marine flood was over Illinois in this case. And of course, we have the
Illinois is the Middle East of coal. It's just we can't burn it here because of sulfur content, so we ship it all to China and they burn it there like their atmosphere is somehow disconnected from ours.
dinosaur deposits, like there at
Except in Illinois, there are no dinosaur age. There are some Cretaceous, but it's river. But the coal's Carboniferous, Pennsylvanian subsystem, specifically, sub-period subsystem. So, yeah.
the Dinosaur National Monument.
Oh, see, you just jumped from Illinois
1,500
to.
bones on the quarry face.
Yeah, and you look around at the sediment to see the environment that they were deposited in. And what you'll find is they all die together in a mass flood, like a river flood. These would not be jumbled all together like this if you had a global flood ripping across the continent at a meter per second. Some of these would be in Illinois, and they're not. Or, Hudson Bay, or in Igaliku, Greenland, and they're not.
Quarry sandstone. And you see the way dinosaurs were buried in some type of slurry flow, like and very high sediment concentration flow.
Nah, that's an okay description, but we can do that with a river overflooding its banks from a rainstorm higher up in the headwaters.
Not a normal river deposit that buried these dinosaurs.
He did say not a normal river deposit. So I guess technically, if you're going to argue semantics, he's not wrong. But the big
And
picture is wrong.
in Texas, we see
By the way, people who argue semantics annoy the crap out of me, so don't do it, please.
here a 3-foot thick layer of what? Clams, clam fossils dominantly, whole clams.
It's a pack stone.
Okay, how did whole clams get buried?
They lived together and died together in a subsiding basin. But you know what? You can also get carbonate rock from precipitating out of solution. So you can't get carbonate rock thousands of meters thick to precipitate out of solution in a year, much less become lithified and then eroded because there's unconformities on this stuff. Oh man, these are meant to be gotchas, or in Steve's case, point illustrations. See, this fits to what I'm saying. but he doesn't tell you everything else that doesn't fit. And all this bed tells us by looking at it is we have a about 1 meter thick bed of dead things. It doesn't tell us about how they died necessarily. Obviously, they're marine, when they're in carbonate rock, they're marine animals, so we can determine that much, but we have to look into the sediments themselves to determine what happened. We don't just assume what happened. And I get that a lot from young Earth creationists. They think our geologic interpretations are just as valid as theirs because they think we make stuff up. And we don't. Geology is a predictive science. There's a reason why they call geologists secular geologists when they want to find an ore bed traced into the subsurface and not Steve Austin or Eric Hovind or Ken Ham because they don't have a model to use to make predictions. We do, and they work. Structural geology is all about modeling and predictions.
The muscles and ligaments were holding the shell shut. You know, when clams die on the beach, they fall apart. The hinging ligament pops the shell open. Natural.
We have plenty of fossils of clams and other things in limestones that are not intact. And there's not like this layer is global or anything like that. And it probably doesn't even extend out of the area that much.
Tendency when the muscles are in there that holds the valves, two valves of the clam shut. So rapid burial, I see that all around.
Yeah, but we can observe rapid burials from debris flows today. Another one would be from volcanism. Ash flows can bury things pretty quickly. But once again, where's your houses and huts in your Salk sequence? They're not there because they didn't exist then. There's all kinds of things that could bury things quickly. Flash floods. This is not foreign to humanity. What is out of our experience is a global flood with waters ripping over continents at a meter per second. That doesn't necessarily mean that it couldn't happen because we can't picture it. The fact that we can't picture it means we need to model it to make predictions. We need to create models. And the predictive part is key to falsification. Presenting a model without telling me how you constructed that model and giving me the details doesn't help. If I just write a bunch of equations on the board, random equations, and tell you that's my Great Flood model, okay, that doesn't tell me anything. Where do these equations come from? How did you derive them? What do these symbols stand for? Can I use these to predict sediments I should see? If the answer is no, 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 and no, then you don't have a scientific concept.
Volcanism and earthquakes. Let's talk about how magnetism is preserved. When a rock cools from a molten condition, lava flow cools, at the moment it crystallizes at a certain temperature, it records the magnetic field of the Earth.
That's true. That is true. As long as it's a mafic rock, like a basalt, or a peridotite, something that has a lot of iron in it, it will lock in to wherever magnetic north was at the time. Now, you've all probably seen the seafloor ones. As the seafloor spreads, you get north, south, north, south. That's how we know the poles have flipped. But you can get them on the continents too, believe it or not. We have basaltic dikes going through every place on we have these things called dike swarms. So, and I've been out with people in the Keweenaw dikes so we can get the polar arrangements or reconstruct our paleomagnetic concept. So you drill into these, you just drill into the mafic rock, and when I see these 1-inch holes out in the field at a half circle, I know exactly who did it. But it's about a 1-inch hole. You go in, you take a core out, 1 inch is what, 2.5 centimeters wide. Goes in about 2 inches to an inch. No, it doesn't go in that far. Oh man, I forgot. It's about half. So it's about half an inch to an inch down. You pull the core out. Then you have to get your orientation of that hole so you can reconstruct. So then you do a Brunton type thing to make your measurement, and we take it to a lab. And I've been in Michigan Tech's core lab to get paleomag. I've even helped them with it, categorize and log them. I'm not a paleomag guy, but I know enough to be dangerous. So we can get continental arrangements too in the deep past, because the oldest ocean crust, not the very oldest, there's exceptions to this in the Mediterranean Sea, but about 200, 250 million years old is our oldest ocean crust, because that gets recycled into the Earth. Continental crust does not. So we can make continental reconstructions back to Rodinia or Nuna or before that. Nobody's really working on before that. Everybody's concentrating on Rodinia right now to lock that down.
We have a lot of reversely magnetized rocks and normally magnetized rocks. And it appears that
Normal magnetizing rocks means North Polar. It pointed to the North Pole. Reversed means South Pole.
the Earth's magnetic field is flipped during
Yes.
Noah's flood.
It's true it's flipped, but Noah's flood didn't happen, so that's not when it flipped.
And this idea has led us to understand that large masses of seafloor are reversely magnetized, and this magnetism was imprinted rapidly. Like on Steen's Mountain, one lava flow has two different directions. And that indicates that the Earth's magnetic field within a week or so can reverse.
You don't know that, Steve. You don't. There's no way to know that unless you date the rock too. And we date the rock, and that's not what happened. Does Earth's pole take 500 years to flip, or does it take 5,000? It could vary. It could be 500. It could be 5,000 times. It could even do it kind of haphazardly, but it doesn't do it in a day. And not to mention, we have others on the continent that predate the ocean floor.
And so a loop of magnetic flux probably created at the core mantle boundary can transit through the mantle of the Earth to the crust and be imprinted in lava flows. And so the probably plate.
That's not what happens. He doesn't know how that happens. What happens is you have this hot melt with the mineral assemblage to make a mafic rock, so it's got iron in it. When it cools, the crystals will align to magnetic north. Now, that could sometimes be pointing south because the poles flip, but wherever magnetic north is, that's where they point. Sometimes they point north, sometimes they point south. Right? That's not what happens, Steve. It has to do with the crystallization. Just like I can take an ironstone, like a magmatic ironstone, like I actually have some in the lab. I have some from Missouri, and if I put those in an oven and heated them up to the curry point for about 24 hours and tried not to melt them, that iron would align to magnetic north in that rock. So it has to do with heat and cooling. It doesn't have to do with being deep in the mantle. Who is this? Oh, Prezo. Anyway.
Plate subduction is one of the processes that initiated the reversal of the Earth's magnetic field.
We don't know that. There's no way to know that. We don't know exactly what. We have models where it automatically flips, which wasn't put in there, but that doesn't tell us why it flips.
And around this Pacific Basin, we have the Ring of Fire, the Pacific Basin, but it's really the basin of fire, isn't it? We have all of these earthquakes and all of volcanoes. Anyway, you can see where the modern earthquakes are. They're in belts around the basin, and that's where the plate subduction occurred. And so we're seeing the residual of.
Except this is a spreading center, and this is a spreading center. This is subduction all up here, and down here, South America.
Are going and retreating. So it's an oscillatory motion, it seems like. And the waters were coming and going.
That's an assumption. That's an assumption. I don't see it saying oscillating waters. I think someone would notice that too, Steve.
Until the 10th month. So the middle of the flood, at the end of 5 months, this unusual 6 months, the end of 6 months, this unusual going and retreating is happening until the 10th month. So it's there's a large amount of that. And we look at the
Grand Canyon, once again, as if that's the lab representative of the entire planet.
Look at the surface of the Colorado Plateau. You can see it's beveled off. And the beveling of the retreat of the waters of the flood seems obvious.
Just real quick, he's talking about this land surface, modern land surface. And they like to talk about this. So the flood waters are treated after depositing all this, then the canyon was carved out. If that was true, we'd have these canyons everywhere on the planet, and we don't. This is not what a receding floodwaters produce. They do not produce meandering streams. Never has anyone produced that from something happening like within a year like that. It doesn't happen. Now, there's different theories as to why this happened. We're actually moving back to the original. But the whole Colorado Plateau has actually been lifted up due to the mantle underneath as a whole thing. This happens. We've got other places in the world this happens. So you're really high above sea level here. It's not like this is sea level down here. So it's high. And, you don't get these meandering patterns in flood, especially just one. I mean, there's not like we have 20 of these side by side. So, but if you don't know anything about how canyons form, would you disagree with the guy? He has a PhD, right? So he's got to be right, even though I'm pretty sure, I don't, where did he get his doctorate in? I'm not going to say because I don't know. I know, but I'd forget.
To
Anyway.
me, the canyon was formed in the post-flood period. The, the retreat of the floodwaters was generally over a sheet-like area, and so it beveled off the top of the plateau. Okay, so post-flood geologic process. We have tectonics, we have volcanism, we have sedimentation, we have erosion, global cooling. And the post-flood world cooled. And
Oh, this is where they're going to try to put the ice ages into it. But those of you that follow me know I study rocks at ice age deposits or of ice deposits, diamictites, the old tillites. Trouble is, they're not 20,000 years old. They're not 100,000 years old. They're not 2 million years old. They're 2.5 billion with a B years old. A little younger than that. And there's different ones younger, like 2.43, 2.27, stuff like that. But basically, in the early Paleoproterozoic, we had ice sheets. So how do you account for those? And those are in the Herodian supergroup, and they are buried. How did those get there? These Precambrian rocks, I've heard you say nothing about, Steve. Absolutely nothing. So the Quaternary ice ages are not the only time there's been ice ages on Earth.
the intensity of geologic process declined. And the raininess of the post-flood world declined to the present arid Earth. And then we had an ice age. So a lot of things are happening in the post-flood world. So
A lot of randomness. Where's your model for this, Steve? Why do you have any, even like some storyboards at this point, I would entertain? You're just making statements and showing a general flipped logarithmic graph. I mean, these are claims, Steve. These are claims. You got to have the work to back this up. Maybe you do somewhere, but you're not presenting it here.
exponential decline of process in the post-flood world from the very high, very potent geologic processes that were initiated by the
Sisyphus.
ground at the Tower of Babel.
I apologize again for scratching my nose. My allergies are really acting up.
Rather than go out over
Who cares?
equal pressure with depth, allowed the certain parts of the continent to sink and other parts to rise. Ocean floor was hot, right? And what happens when hot ocean floor cools? It becomes higher density and sinks. And so in the post-flood period, the cooling ocean floor.
Yeah, how did you subduct those warm ocean plates, Steve? Because warm ocean plates are going to be more buoyant. We see that. That's why we have mountains around the mid-Atlantic ridge, because it's still relatively warm. It's more buoyant than the surrounding old crust. That's generally what we see at the spreading centers. We generally the ocean floor sinks lower and lower and deeper to get to a subduction zone because that's the old thick rock because the crust is thickening in those areas too. Where is this? This doesn't make sense.
As it cools, it
Doesn't make
sinks. And so
sense.
what happens? The continents appear to rise relative to the ocean. And so
So now you have plate and lid tectonics in operation simultaneously. That's a new one. You think someone would definitely notice this going on.
in the post-flood period, it looks like the continents are emerging out of the ocean. And that's what we indicate and see. Base of that cliff, you can see
So
the
here, okay. This isn't the Grand Canyon. Snelling actually put it as 2021 paper. There was a fault here. He doesn't. He just showed. Well, let me get. Let's see if he shows it.
people.
All right.
People down there.
Yeah.
Okay, and
Okay.
sandstone is twisted like taffy. This is the rise
That's an okay description for a layperson. I don't have a problem with that. But there is a fault here that he just skipped over.
of the upwarp in northern Arizona called
Assuming this actually is a syncline and not just an optical illusion, you get those form through compression. They don't form through extension. Not this stuff. The fault like this was formed through compression. You can tell because your hanging wall versus your foot wall is reversed. Not going to get into all that. Talks for other times. Look them up if you want. And you can also use the stratigraphy. Like if we saw, this is what happens here. We see this, if this was a distinct unit and then we saw it up here, we would know this right side was upthrown against this one. You can get false and extensive, that's true, regimes, but not in this case. I'm pretty sure because that's not going to form a syncline. You're only going to form a syncline if this is lifted up and puts pressure on this. Otherwise, this wouldn't happen, not this tightly. But like I said, I don't have any structural measurements, so I'm just making interpretations off a photo. I could be completely wrong, but I do know there is a fault in this outcrop somewhere because these guys never put like Snelling's 2021 paper, which I did a critique on that's also on my channel. He takes 10,000 pictures, not that's an exaggeration, but many, many pictures of the great unconformity, draws the line on it, puts it there, and then he shows pictures like this with absolutely no structural context. None. Which makes me wonder if you can take strike and dip in the field. That's all you got to learn how to do. Lineations, basic stuff.
the Kaibab upwarp. And the upwarp occurred in the late flood.
Upwarp isn't a term we use, but he is talking to laymen. And unlike Eric Hovind, none of these come up. And he doesn't make the terms up, then use them over and over. So I don't have a problem with him using these generic terms. If it was Eric doing it, I'd be on him like flies on shit.
So-called laramide orogeny, and this created the
Orogenies are mountain building events. Those happen through compression when two plates collide. Now, you can get mountains other ways, but in this case, that's not relevant.
monocline called the East Kaibab upwarp, and that feature created the blockage that allowed water to pond behind it and allowed a big lake to build up. And that lake was later breached, its dam, and became Grand Canyon. Lots of volcanic features to
No evidence for that.
talk about. Shield volcanoes and composite cone volcanoes like Mount Rainier, Mount Baker, Mount St. Helens, Mount Adams. Down in Oregon,
Yeah, because you have a subducting plate over here, and initially that's going to create a lot of friction as it goes into the mantle over this continental plate, and it's going to cause melting. It's also introducing water, lowering the melting temperature even more, and you're going to create new melts rising up through the crust.
we have Mount Hood. Okay, cinder cone volcanoes, lots of lava flows, things like that. Calderas like.
Well, the geology is more complicated than he's getting here. Some of it's due to the subduction, but we also have extension in the basin and range area, which is not part of the Colorado Plateau. But he's mentioning cinder cones and stuff because I have no scale of this map or this block diagram. It's just, and I don't know how far these things are apart, if that's relatively correct or not. I don't know. Just scale. This is basic thing. Scale in a north arrow. I've said this so many times. It's 101 stuff, guys.
Crater Lake. And so magma, especially magmas here in the under the western United States, are expressing themselves late in the flood and in the post-flood period.
We could date those rocks. If that was still happening, the amount of time it takes for that to buoyant melt to rise up through the crust is beholden to the laws of physics, just like the crust would melt if we started jamming it into the mantle at 2 meters a second. The laws of physics prohibit all of this, and these aren't laws that we're iffy about. These are laws that we're pretty confident about. So this doesn't fit into that. It doesn't match with what we observe in geology. It doesn't fit into physics. So you not only have to disprove, falsify entire theories in geology to make this work, Steve, but you've got to basically rewrite the laws of physics too, and chemistry, to get any of this to work. See, this is too big of a scope for you to try to even do that, because you would have to falsify all these other things and come up with alternative testable models, not just talk about it and how it happened. I can talk about anything. Talk about the dragons that rose up through my backyard last night and planted some trees over there just to burn them down with their fiery breath. Doesn't mean it happened.
Large plutons of granite, like in the Andes Mountains, have cooled. We see out in eastern Oregon, like
Well, we have granitoids throughout the continent as well. Pinocchio neurogeny has them because that's an old continental margin. You know, Rodinia, actually, before Nuna even, Pinocchio neurogeny occurred. The Pembine-Wausau was accreted. Yeah, this doesn't fit anything we observe. You can't just go, just point
in the
places.
John Day country, great.
He's actually is trying to expand, though. I'll give him credit here. He's trying to tie it into something other than just the Grand Canyon, like Eric Hovind does.
Masses of volcanic ash. John Day.
I'm going to skip all this. This is just unless something else comes up. Oh, here we go.
Post-flood period.
Let's go back. You guys got to see that. All right. Of course, something comes up.
Linear fracture system.
Fast forward.
And the buildup of deltas, like this is the Nile River Delta, and the Mississippi River Delta. That's been prospected for oil, and it's a deep delta, many miles in thickness.
I don't know how thick it is. I don't know enough about the Mississippi Delta. But what you do see here are folds. Something tells me that these are not delta deposits, and this looks like basement rock reflection to me. And this is probably older than that, so you have some sort of deformation forming synclines and anticlines. But I don't know the geology, and he doesn't explain it. If I was to pick out the delta deposits, if that even duplicates, I don't know the scale. I would say they're probably just right here. And maybe right here. But I don't know, because there's no scale once again. There's no explanation once again. I can't read anything on here, but that's not because of him.
Of sediment.
I mean, I know he's talking to lay people, but still, you need to explain this stuff.
Has been accumulated there in
Give them credit that they're not like grade 3.
the post-flood period. And a canyon erosion, like a Palouse River Gorge here in Washington State, 400 feet deep, several hundred feet wide.
I don't know if he talks about the scablands, but the scablands do not look anything like the Grand Canyon. The scablands did form, I think the Lake Missoula glacial lake broke up. So that, yeah. But I don't know if that's what he's talking about or not. But those of you that know the scablands know. Even look on Google Earth, you'll tell. They look nothing like the Grand Canyon. Absolutely nothing.
6 miles long, gouged out by what? The great glacial flood from the broken ice dam there in Missoula, Montana.
Okay, must be talking about the scablands.
Lake Missoula flood. And the Cordilleran area in Idaho, that was a great ice dam there that broke. And Grand Canyon was breached by the lake, that, or series of lakes that were there on the Colorado Plateau. So you
There are evidence of some lakes on the Colorado Plateau, but they were nowhere near massive enough to contain enough water to do this. Some guy actually tried to model that because it was thought that maybe the canyon did form relatively quickly. And you can get meandering deep canyons to form in a model, in a physical model, if you do it really slowly, the water. I mean, quick in geology terms, but slow in a human lifespan. Because if you just get a flash flood, essentially, it does not form a meandering stream. Well, as it turned out, he turned out to be wrong. It was falsified. So we went back to other stuff. So the canyon did not form quickly.
can imagine various lakes on the Colorado Plateau, the dam through the
We're just going to skip all this. I'm just going to keep going here.
ice age occurred, and now we have a little bit of global cooling, warming, and left things like Yosemite Valley. So the whole global circulation pattern has changed during the ice age, and then following, we're living in the after effects of this global ice age.
We are actually still in the global ice age. The fact that we have continental glaciers to the extent we do, although they are receding, shows we are still in that ice age.
And the global ice age occurred, and now we have a little bit of global cooling, warming, and left things like Yosemite Valley, beautiful valley.
Glaciers can move boulders hundreds of kilometers. They do it. And that's what we see at the bottom of a moraine. We'll see a lot of local stuff, but we'll also see a lot of some foreign stuff. So your ancient flood should have done the same thing, and it didn't because it never happened.
A U-shaped valley, which was filled with glaciers.
That's true.
Now the glacier is largely absent, just in the upper part. What are they going to do in the summer when they can't find shade? They're going to die of heat exhaustion. But what happens? They found that there's a cooling behavior. Elk like to cool themselves in wet soil, and they go in to take a siesta, and they do fine. In fact,
Yeah, animals learn how to deal with the weather. We put on clothes. We heat our buildings, air condition our buildings.
more elk in the blast zone, I think, than in the surrounding forests at Mount St. Helens. So elk are amazingly versatile animals. And
Yeah, so what? That doesn't mean anything. Has nothing to do with the global flood. You'd have to make a massive stretch to even equate the two. Plus, Mount St. Helens did not happen in a flood. It was volcanic eruption. Yes, stuff did fall into a lake there and scoop out the lake, but a lake is not a planet.
so we imagine all kinds of animals distributing widely in the post-flood period. And then, of course, the
And then we run into the problem, how did they get there? And there's been wacky stuff suggested, like koalas getting shot out of volcanoes. I kid you not. That's so these animals had no way to get to where they are. No way. Absolutely none. So and they just happened to divide out. See, that was you talking about the elk. Like the elk can live within a harsh climate range. Yeah, but there's a limit. You drop an elk, one of those elk in Antarctica, they're going to freeze to death. They can't handle the extremes. We as humans, if I was to walk naked, subtropical zone is probably where I'd be able to, with low temperature fluctuations, where I'm going to do the best. You drop me naked in Antarctica, I'm going to die. You drop me naked in Death Valley, I'm going to die. All animals have different ranges they can tolerate. That's not an argument for anything. You still have to explain how they got there. There's no explanation for that. Not to mention the rapid reproduction and the fact they all can't fit on the ark and all that other stuff we've all gone through so many times, and no one listens. Well, no young Earth creationist listens anyway.
Earth became more arid. Okay, the raininess declined, and now we have great deserts like the Sahara Desert. But the Sahara Desert was once a lake. There's lake sediments underneath.
It's not entirely true. They love any thick deposit to call it a lake for some reason. They did that Baraboo too. He didn't say it. What's his face said it. He's not even a geologist. claimed the Baraboo quartzite was a lake deposit, and it's not. If you actually studied the rocks, you'd know. But yeah, that's. I think I know what lake he's talking about, but the whole thing that wasn't intercratonic or epicontinental sea at one point. That's why you find whales out there. You don't find them out there because of the Great Flood. Because if that happened, we'd find whales at the base of the Cambrian, and we don't.
The sand of the Sahara. And great river valleys were open.
This is Grand Canyon. See how that meanders. Catastrophic outflow of water cannot do that.
And
People have tried to model it. If you don't believe me, try to model your own.
Drainage of lakes created canyons. There's the Earth, the post-flood Earth.
Yeah, it's Earth. Okay, let's move on.
I've integrated plate tectonics into my flood model, and I hope you can understand a little bit about what that's like. But earthquake focal mechanisms, earthquake distribution globally, these big faults, detachment faults especially, that make up mountains.
Okay, he was talking about detachment faults before, not debris flows. But you didn't say that before, but that doesn't matter because he probably just skipped over it. But you are talking to people who don't know what you're talking about. I've done it too. That's an honest error. But detachment faults, that's something else. And I'm not an expert in detachment faults, but my mentor is.
That fits nicely with my view of plate tectonics. The way the
All right, we're going to skip this summary just to see if anything else comes up. I don't remember.
Before
Okay, we got questions.
had oceans, evaporation off the oceans,
This I'm interested.
flood.
Okay, as far as I know, these people are laymen because that's how he's been talking to them. So I'm not going to assume any question is stupid. There's no such thing as that. All right, I will entertain any honest question anybody has.
volcanism, the fountains of the great deep.
But if you come at me saying plate tectonics is false because life can't come from non-life, I'm going to ignore you because that's not a place of honesty.
Can be accommodated within this model, and things, other kind of things are all out there. So that's global tectonics and plate tectonics. Thank you.
The Bible talks about no rain before the flood
that's loud.
and heavy rain during the flood, and then rain continuing after the flood. Your model with oceans and so forth before the flood would have given rain before the flood because you had oceans, evaporation off the oceans, and then any wind of any kind to move it over land. You would have had some rain before the flood. Also,
That isn't a bad. I know what he's trying to say there. That's fine. I don't have a problem with that.
Okay,
shift. I only have two. The other one's the shifting of the Earth's axis. If the Earth's axis wasn't shifted, it would contribute to no rain. The Earth's axis being shifted is a significant contributor to the rain patterns we have today. And
Okay, he's one of those crustal sliding guys. I think that's what he's talking about. Einstein was actually a proponent of that, but that was granted he died before plate tectonics. So
could you explain those two?
Okay, I'm not so sure that we have all the facts here
is that Ken Ham? I don't know.
right, but we had oceans before the flood, and what does that scripture? So it's basically a dominant is a scripture problem. You want to talk to Larry Varnum about those issues? Okay, that's who you want.
He asked those questions that science should be able to answer, and Steve did not have an answer. He said, consult scripture. Just say, I don't know, Steve. Say, I don't know.
I want to talk to you. Don't want to talk to me. I'm into tectonics of plate motion, not into the atmospheric modeling in the pre-flood period. But we had oceans. Now, what was the rain condition like? I'll let somebody else answer that particular question. But I don't know what the scripture says. And then, how about the axis of the Earth? The axis of the Earth is now tilted 23.5 degrees relative to the plane of the orbit around the sun. Okay, and that's about optimum for creating the climate distributions that we have on the planet. And I think that Earth's rotation.
I misunderstand that. Optimum for the climate. Well, that existing tilt would be optimum for the climate zones we presently see, I would think. But I think he meant to say ideal for, habitable. I don't know what was there. That's just the wording. I'm not going to. Let's move on.
Or the axis of rotation hasn't changed significantly relative to its orbit. I think that's remained largely fixed. I think the rotation rate of the Earth.
Yeah, because that guy, I think, was of the old school of the crust shifting upon the mantle and the core. I've covered those before. I forget what it's actually called. I fail you. Now, the planet spinning faster. Yeah, it did. Billions of years it's been slowing down, but you can only spin it so fast too before it flies apart too, Steve.
Is slightly accelerated due to the subduction of the ocean floor.
Okay, he said slightly increase. Why would subduction of the ocean floor increase rotation? Is I've never heard that. That's just something I've never seen documentation on that.
The
So let's
Earth's
leave it there.
rotation rate has sped up slightly, like a skater pulling in her arms. It spins faster. So the Earth's.
Yeah, but that applies to something larger tightening in on itself, like a collapsing disk of dust and gas to form a solar system. It doesn't apply with subducting plates because subducting plates are not shrinking the Earth. They're going inside the Earth at different angles and different locations. That explanation doesn't make any sense, Steve.
The day has changed a little bit, but not much change in the axis. Yes.
Yeah, I had a question. I believe Genesis 7 says that the fountains of the great deep were broken up all on the same day.
That's something?
So I'm trying to understand what mechanism caused the oceans to become torrential rain.
Steve did kind of explain that, but that is a decent question. Let's see if Steve is consistent.
Okay. Well, the scripture says all the fountains of the great deep were broken up on that same day, right? So one day. So it seems like that unzipping that would happen. See, ocean floor has to detach from continent and start to be subducted. It looks like that unzipping process happened very rapidly around the pre-flood supercontinent, essentially. So that so we had a global earthquake event that was created.
Okay, he's being consistent at least. I'll give him that.
Okay, that's what seems to be apparent there. And how does that relate to the rain? Okay, that I can't say. My guess is the new ocean floor that was created and the hot rock that was formed caused the rain. And there could also be moisture in the atmosphere, even a canopy ready to condense.
Those could all be hypotheses if we didn't know what we know. So this is just speculation.
Okay, question here.
Dr. Austin, you showed a graph where you showed the ocean temperatures. I was wondering how you collected the data or where you got it. And the second thing is, if you could comment on the magnetic field change that's currently occurring and what the different theories or ideas are behind that.
Okay.
Those are two excellent questions. I don't know who this guy is, but well played, sir. Well played, whoever you are, whichever side of the fence you're on.
Okay, that exponential decline curve showed oxygen 18 ratio in little small organisms in the Arctic Ocean core. Okay, and that oxygen 18 oxygen ratio is indicative of temperature, and so
that's true.
we think we had a hot ocean, maybe 80 degrees or 90 degrees Fahrenheit.
That's not what the data shows, but whatever.
Even warmer than that, in the Arctic. What would that create? Just think that way, and you can imagine what the ice age must have been like. So that's the kind of thing we're talking about.
I'm not aware of anything that warm. Granted, the ice cap was not always there, but it was never the Bahamas. I don't know where that comes from.
Hot oceans after the flood. And so the hot ocean phenomena and the cooling of that ocean
One of my cats
went
is
through
here.
that exponential decline, and it created the ice age. The ice age is a natural byproduct of the hot ocean, and maybe Dr. Varnum will explain a little more about that. Okay.
Oh, this is where Eric Hovind got that from. He didn't get it from any secular scientific journal. He got it from Austin.
Question over here.
Around Washington State, we have these really thick basalt layers. You don't have to go far to see all the basalt. I'm wondering if your model would show that as being post or current
Say
flood
hi.
catastrophe, or is that more of a sign of erosion, like those basalt layers being put there by lava from cataclysmic, or is that eroded away and exposing it
Sorry.
to us currently?
Okay, when plates were subducted under western Washington,
My eldest son.
it flexed Washington State and created tension away out there in eastern Washington. And at the end of the flood, there was a whole bunch of fractures that were still there. And when the plates slowed down, it created opening of those fractures. We had a linear fissure array that reached down to the mantle of the earth. But over
Linear fissure array? Do you know what that is? I don't know what that is. He knows more about it than Austin, apparently, because he's keeping his mouth shut.
there was no subducted ocean sediment, so there's no andesite or andesitic composition magma. There's just basalt down there, basaltic rock, and so it rose to the
Love
surface,
him, adorable.
and it flooded what, a 250,000 square mile area, creating the
That is such an oversimplistic picture. We actually have plate that's almost been consumed in that area. So the geology is way too complicated there, and I don't know enough about the laramide orogeny, but I do know that is not part of it.
lava flood terrain of the Columbia River Plateau. So yeah, lava flood. Largely in the late
Flood
late
basalt.
flood and into the post-flood is when all this volcanic activity's happening. So yeah, okay. And one last question over here. Okay, yes. Last question.
Hi, Dr. Austin. I was wondering what's going on with the FAST project, and what can we expect you guys to come out with in the next
I don't know what that
in the
is.
coming
Okay.
coming days.
Right. Okay. FAST project. Then we need the break here. Flood-activated sedimentation and tectonics. It's a program. Okay. Flood-activated sedimentation and tectonics is the program. Research program is currently going on with about 6 scientists, 6 projects that are working on supercurrents. The evidence of those sandstone layers showing the great cross-bedding.
Yeah, I mean the Aeolian ones of the Navajo, which are Mesozoic, I believe.
Okay, supercurrents, the Coconino Sandstone Project. And there's another project on, a series of projects on super flow. And I'm into super flows, right? And other people on the FAST program are into.
I'm so using Superflow somehow, some way. I just need to think. Can you help me, bud? How can I make Superflow funny? No, we're not going to talk about that. I know what you're all thinking. We're going to find something else. I should have just not said anything there. It took a while for the hamster to wake up and spin that rusty wheel.
Superflows. How sediment can flow over essentially horizontal surfaces and fly like wings under the ocean and deposit thick masses of sedimentary rocks, like the
Wish I could
limestone
fly
layer
with
in the
wings.
Grand Canyon with the nautiloids, that kind of thing. Slurry flow in Kingston Peak Formation, which I showed pictures of in Mojave Desert. Slurry flow in Alaska, where the plates were colliding head-on. What is a head-on collision going to cause in Alaska? Huge collapse and flow deposits. And so that's what we've been looking for. And then evidence of super faults. That's the other thing that FAST is doing, super faults. Today, when earthquake activity occurs and faults slip, what happens? We pulverize rock. We make rock powder. But in the catastrophic plate tectonics, when rock faulted and slipped, it slipped great distances, and it slipped at about meter per second. It melted rock. Faults can melt rock. We have no modern earthquakes that melt rock.
He did just mention that you can melt rock from friction, though, which is interesting. But to move it that fast, you're going to have a lot more than an 8 on the Richter scale, Steve. Oh.
Okay, but we had earthquakes in the past in this tectonic process that created melted rock. So the FAST program is studying the melted rock on faults as evidence of catastrophic plate tectonics.
Oh, hey. That's it, everyone. I'm going to cut it off here. If you have any questions, and I don't want to hear I was trying to say Dr. Austin isn't, competent or anything like that. It's not what I was doing. I was going through it and showing you the actual science or telling you about it and how his model doesn't fit. And, well, I use that word loosely. Anyway, so this isn't, and I'm not calling him a liar or anything like that, so I don't want to hear any of that garbage. All right? I'm not going to make any assumptions about motive or anything like that, okay? But if you have any honest questions, any honest comments, please leave them below because we would love to read them.